In this next section involving applications or word problems, we need to first look at how to take some of the phrases that we see here and write them algebraically. 8 more than a number. More than is going to refer to addition. And so we can either write this as 8 more than a number, and I will use x, or because of the commutative property of addition, we can write that as x plus 8. It's your choice as which one to do. Now, some people like to say, well, but more than. Can't I go and write this as 8 greater than x? And the answer is no here, because that would say 8 is more than. The is more than is what gives you an inequality, but without the word is, that does not become an option. Subtract 9 from a number. Now we have to look at subtraction very carefully. The 9 is being taken away from the number, and so we're going to start with the number and then subtract 9. Be careful, subtraction is not commutative, and we cannot write that as 9 minus x. In this next one, product refers to multiplication, so we're multiplying a number in 5. So we could go x times 5 that way. We could write x times 5 using a parentheses. What we cannot do is go x5. Okay, that is bad notation. Whenever we are multiplying and we have a number and a variable together, we prefer to have the 5 in front and to write that as 5x without a symbol. That's understood to be multiplied together. But as a convention, the number, called the coefficient, goes first, and x5 is not a proper way to write that. 9 less than a number. Again, I'm not going to be using the less than symbol because that would have 9 is less than. So not an option here at all. I'm taking it off the table. Now, less than here refers to subtraction, and we have to be careful of what's being subtracted from what. 9 less than a number. We're really beginning with the number x and then subtracting 9 away from it. And I'd like to notice that, hey, that's the same as what we had up above. You really have to be careful when you are looking at subtraction and division that you get the order correct. Now we're going to turn our attention to some word problems or applications. And there's a whole lot of varieties, and I don't want to write the whole text out and take up the whole screen here, but I will describe it along the way here. One type of problem would say, I want to buy some floor tile, and they'll describe a room, for example, that might be 30 feet long and 12 feet wide, and they'll ask you how many square foot tiles do we need to tile the floor here. Well, when you see that we're filling in an area, that's kind of the clue that you're going to be finding the area, and that's a multiplication problem, and the area will be length times width. So in our case, 30 times 12. Notice how the 30's got that 0 in it, which I'm going to ignore that 0 for the moment. Go 3 times 12 is 36. And then I'll tack that 0 back on like I showed you in the multiplication video. And I've got 360, but I need a unit for this. We actually went feet times feet, so we're going to have square feet, or feet squared. Now, if this problem we're asking about the room they want to put a railing around the sides here, and you had how much it was going to cost per foot going around the room, that would then be a perimeter model. And the perimeter of this room would be 30 plus 30 plus 12 plus 12. Putting these together, I'd have 60 plus, putting those together, 24. And the perimeter would be 84 feet, not square feet, but just feet. Then if we're asked or told, well, leave space for the door, we'd have to subtract off some space there. And if they told us that each foot of this border is going to cost $2 a foot, we would then multiply by $2 and find out that it would cost $168 before taxes added on. Another type of problem would involve a car and its mileage. So for example, let's say a car gets 35 miles per gallon, and we know that the tank is going to hold 11 gallons, and the question is, how far can this car drive? Well, basically, each of these 11 gallons is going to take you 35 miles, and therefore you can understand that we're going to be multiplying these two numbers together. So here we go, 35 times 11. Start with the 1 in the bottom right corner, multiply it by the 5 and the 3 above to get 35. Put a placeholder 0 in the next row when we start multiplying by this 1 in the tens column, and again we're going to get 35. Add down and get 385 miles. Now, if the problem asked instead, how many gallons would it take to drive 400 miles, and we're not given this, you'd say, oh, now I've got this 35 miles per gallon. How many gallons will I need? How many times does this go into? That would tell you we're dealing with division. And so we take the 400 and divide by 35. 35 doesn't go into 4, but it goes into 40 one time. 1 times that 35 is 35. Subtract and get 5, bring down the next 0. 35 goes into 50 one time. That would be 35. We would subtract and get 15. And basically we need, I'm going to go remainder 15 in this case, but we're going to need more than 11 gallons. 11 and 15 35ths, or something along that. More than 11 gallons are going to be needed to drive that 400 miles. Another type of problem might involve shopping. You might be somewhere at a baseball game, for example, and hot dogs are $8. And we might say that soft drinks are $5. And we want to purchase some of these. So we say, okay, let's pretend we're going to buy 4 hot dogs and 3 drinks. Well, in this case, you'd say, I'm going to have 4 of the $8 items plus 3 of the $5 items. We're going to spend $32 on hot dogs and $15 on drinks, which would bring us up to $47 altogether. And that might be the problem right there, but we might also be asked how much change would there be if a person brought 3 $20 bills. Well, 3 $20 bills is $60, and if we're purchasing $47 worth of merchandise from $60, then we would have to find out that the change is going to be $13. It just depends upon the problem that you're looking at. So read your problem carefully, determine what operation is needed or what operations if it seems to be a multiple step problem, and then if it's too hard to do in your mind that way, make the numbers simpler. Sometimes our brains can handle it better when the numbers are simpler. And then dive in and just check your answer and ask, is this reasonable? Word problems are not something that needs to be feared.